Today we're going to be talking about the scientific method. And you might be asking yourself, what is the scientific method? Or maybe you've heard of it in some class in the past. I've seen a lot of classrooms that have posters on the wall that have 4, 5, 6 steps, and they call it the scientific method. It's a good general description, but in reality the scientific method is a lot more messy than that. Okay, the steps are kind of interchangeable, but we can still name a few things right off. One is observation. Just looking at the world around you and asking questions. Something simple as, why is the sky blue? Why is the earth round? Or more complicated, like, what type of soil conditions are best for peanuts? Or are humans contributing to global climate change? No. We don't jump right into experiments. First, you want to think about your topic and do a little bit of maybe background research. But the important thing at the beginning is thinking. Critically thinking about what you observed about the world, the question you had about the world, till you form a hypothesis. A hypothesis is an educated explanation. A good hypothesis is something you can test. That's the mark of a good one. No. You don't want to jump right into experimenting, okay? That's how you end up with disasters. We don't want to have a disaster on our hands. First, do the research. Now, when you go and do research about your topic, always remember to consider your sources. Might be a surprise, but not all sources are equal, and not everything you read on the internet is necessarily true. I know, big shock. But there are certain places you can turn to for reliable information. A good place would be scientific journals. Scientific journals are professional journals put out by scientists that go through a big process called peer review. Now, later on in the course, we'll talk about peer review a little more deeply. Suffice to say right now, it's a process where scientists beat up on each other. It makes it very difficult for false information to get through. Okay, I know you're ready for the experiment. Yes, after you've done all the research and stuff, it might be time for an experiment. But experimentation is just one way of testing our hypothesis. There are other ways. For example, you may just be doing observations. Not everything takes place in a lab. For example, you may have a hypothesis about the behavior of certain animals, and you want to observe them in their natural habitat. Or you may be observing something like pictures taken through the Hubble telescope. You can also use models to test your hypothesis. Wait, no, that's not what I mean. Not those kind of models. Get that off of there. Right, scientific models. And scientific models are models that are created for big things we can't necessarily observe directly, like the formation of the solar system, or the evolution of species from a common ancestor, or something really big and complicated like the global climate. A lot of times you have to have computer models and stuff to simulate, and then you look for evidence based on that. Now, if you've done all this stuff correctly and you've tested your hypothesis, you want to record your results and then analyze them. Analyzing means just thinking about them, honestly looking at the results and determining do these results lead you to a certain conclusion. And that's what we're about to get to now. After all of that, we've arrived at the end in what we call our conclusions. Now, our conclusions should be objective, cautious, and reproducible. What do we mean by objective? Well, objective means to be aware of your own bias. Maybe you wanted the results to come out a certain way. That should not interfere with what the results really are. You need to be able to look honestly at the results and say what they really are. You also need to question everything about your own experiment. Be aware that you may have made mistakes in your experiment, so you're always cautious about the results. And finally, make sure it's done in such a way that other scientists can come behind you and reproduce your experiments and hopefully get the same results. And if you're doing all this correctly, congratulations, you're probably doing science.